We're now going to cover differentiation, part of Calculus Grade 12. Here is the first question where we are required to get the first derivative. Now, in order to differentiate this, the first step is to simplify the given equation. So how do we go about doing this? Here is the order of simplification so that you can differentiate. Now it's important to remember that there are 3 steps that you need to do in order to simplify the equation before you can differentiate. Firstly, we check for brackets. If there are brackets, we try to get rid of them by multiplying. Secondly, if there are surds, now you guys learned in grade 11 that surds can be written as exponents. So if we have surds, we convert them to exponents. Third, we check for variables that are in the denominator. Now, just like solving for x, we cannot solve if we have x in the denominator. Much like that, with differentiation, we need all variables, so all of the x's to be in the numerator only. So we check for variables in the denominator, and if we do have some in the denominator, we simply move them to the numerator. Once we've done these 3 important steps, we then go on to differentiating. When we differentiate, there are different notations that fall under the section of differentiation, so we make sure that we use the correct notation, and thereafter we prefer our final answer to have a positive exponent. Now, when you look at some past papers and you check the memos, some of them are very particular where they specifically look for positive exponents in the final answer, while others are not that strict. But just for the sake of making sure that you get all your marks, we will always simplify our answer until we have positive exponents in the final answer. Now just remember that this is the order in which we work. So looking at the question, the first thing we check for is brackets. We don't have any brackets, so we can go on. We are now checking for surds. And we notice that we do have, it's actually here, we do have a surd. We've got the square root of x. So our first step is to change that surd to an exponent. So we will rewrite this as f of x is equal to negative 3x squared. So the first term will stay as is because it has no surd in it. But the second term can be written as 5, and important to remember that a square root can be written as an exponent of 1 over 2. So this becomes 5x to the power a half. Okay, so we are done with the second step. And then we check for variables in the denominator. So looking at the equation that we have, we do not have any variables in the denominator, so we are good to go on to the next step. The next step is for you to differentiate. And when you differentiate, firstly, your left-hand side now becomes f prime x. On the right-hand side, remember the rule that we use. The exponent multiplies with the coefficient. So 2 times negative 3 gives you negative 6. And you minus 1 from the exponent. 2 minus 1 is 1. We're going to do the same thing for the second term. Exponent multiplies with the coefficient. 1 over 2 times 5 would be 5 over 2. And we minus 1 from the exponent. So a half minus 1 is negative a half. Now I just want to show you here that where I've written 5 over 2 and I've kept x in the numerator, this is the same thing as saying 5 over 2 x to the power negative a half, where instead of explicitly showing x in the numerator, you just write x on the side of the fraction. So these two are the same thing. But I prefer if you guys write x in the numerator because of the last step. So this will make sense a little later on. Now, we've differentiated, but have we used the correct notation? And what do I mean by the correct notation? The correct notation means that instead of writing f of x on the left-hand side, you write f prime x. So sometimes it's very easy for you to forget because you focus so much on differentiating the right-hand side that you often forget about what's supposed to go on the left. So I've included Cn in our steps just to remind you that, hey, you need to use the correct notation. And lastly, we need to make sure that there are positive exponents. So we've got f prime x. The first term is fine, that can stay as is because we do have a positive exponent. And what do we mean when we say positive exponents? We are referring to the exponents of x. Since x has an exponent of 1, we don't need to write that. Now, in the second step, in order to make the exponent of x positive, what you do is you take your variable and you move it to the denominator. So the 5 will remain at the top, but x now goes to the bottom and its exponent becomes positive. So we now have 5 over 2x to the power half. So this is why I prefer that when you're differentiating at this step, I kept the x in the numerator, just so that later on when I moved it to the denominator, I knew that, okay, it's in the numerator, I just move it to the bottom, and its exponent becomes positive. So this is your final answer.